I gotta set my literally. Oh, how? Like, what do you do? Literally, do you run in the morning? Do you run in the morning?
Fury ball.
Yeah, I'm at 500
We sit in.
right now.
We start
Schoolwork is hard. A lot of writing.
Okay, so anyways, now that we're recording, I want to take the integral of a to the u du as opposed to x squared, where we have a variable raised to a constant. Again, we have a constant raised to a variable. So if you think of that as being e to the x, when we took the integral of e to the x, what did we get? E to the x. So the same thing is true here, a to the u. The only thing you need to remember is you need to stick a 1 over the natural log of a on there. And then, of course, it's an indefinite integral, so you have a plus c. Now, some of you are still doing silly things like taking derivatives and ending a derivative with plus c. Don't do that. Some of you are doing an a definite integral, plugging in the numbers, like from 2 to 3, getting an answer of like 14, and then sticking a plus c on the end of that. Don't do that. That's not good. Okay. So it's its own integral, but again, you have to multiply it by 1 over the natural log of a. The tricky part is dealing with that a, so we still have to do u du stuff. Example number 1. We want to find the integral of 3 to the negative x dx. It would be easy to say, well, that's just 3 to the negative x times 1 over the natural log of 3, but it's not that easy. You have to do a u du problem. Is your answer going to be completely wrong if you don't do a u du? Well, you'll lose necessary components, and you'll see what happens when I do this problem. What would you like u to be? Negative x works well, so du is equal to negative 1 dx, so dx is equal to negative 1 du, which means this becomes the integral of 3 to the u power du, but there's a minus sign in front. So again, if you forget the u du, you're going to lose that minus sign. Doesn't seem like a big deal, but it is. So what's the integral of 3 to the u? Here, let's clean that. And then negative 3 to the negative x times 1 over the natural log of 3 plus. Sub that back in. Okay. So again, still a u du problem. Let's do one more example here. I think I can sneak it in over here. Example number 2. Integral of x to the 4th times 9 raised to the 4x to the 5th plus 2 dx. Sorry, the shoes are very squeaky. That's why I mentioned it, because now you're going to obsess on it. That's all you're going to hear is constant raised to a variable. So we're using this formula. Obviously, we're going to use this formula because that's what we're talking about, but later on when you start amassing all these different problems, you need to be able to recognize that this is in fact a constant raised to a variable. What's u? Du? Am I happy about that?
Yes.
Why? Cancels with the x to the 4th over there. So dx is equal to 1 over 20x to the 4th du. Real quick for the Grassyites in the group, did he have you doing this the same way where you solve for dx?
Yeah.
You don't know. You have no clue, do you? You just, yes.
Oh wait.
Did you actually solve for dx for your substitution?
No, we just kept it as du.
And then move that over together. Okay. I like this technique better, but you can do whatever you want. This is American. That's about right. Alright. So what's going to happen here? Well, this becomes the integral of 9 to the u. That's the easy part. So that becomes u. The x to the 4th here is going to cancel with the x to the 4th there. That goes away, and then I got a du, and what am I missing? 1/20th. Let's jump down here. So 1/20th, what's the integral of 9 to the u power? 9 to the u times 1 over natural log of 9. Plus c, very good. Which is, let's see, we can do 1 over 20 natural log of 9 times 9 raised to the 4x to the 5th plus 2 power plus c.
All right.
Wow. Santa for me. Took care. New shoes, new sweater, new attitude.
New me.
Alright, any problems? So this is our other formula that you need to burn into your brain. So whether that means making a note card or putting it into a flashcard app or whatever you do to remember that formula. But that's the about the only one we're going to deal with integrals. Yes, sir?
Is there another one for the log, the other derivative equation that we did yesterday?
The other derivative equation. No. Okay, we good with that?
Yes.
Alright, let me stop the recording and then we'll go over some homework.